Preparing for a front-end engineering at Vercel interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you improve the performance of a React application serving users globally? I would begin with measurement, using field data and Lighthouse to identify the largest bottleneck. Then I would optimize LCP with responsive images, fonts, caching, and server-rendered critical content. Reduce JavaScript through root-level splitting and dependency review, and improve INP by breaking up long tasks. On Vercel, I would use the CDN, streaming, and framework-level optimizations. I would validate every change with real user monitoring rather than relying only on synthetic scores. While answering, cover core web vitals, code splitting, image optimization, caching, streaming, server rendering, CDN delivery, hydration cost, measurement tools, and prioritizing improvements based on real user data. Question 2. Explain the difference between server-side rendering, static generation, and client-side rendering. Static generation produces HTML ahead of time, making it fast and highly cacheable, while server-side rendering creates HTML per request for fresher data. Client-side rendering sends a minimal document and builds the interface in the browser. I choose static generation for stable content, server rendering for request-specific or frequently changing data, and client rendering for highly interactive areas. In Next.js, these strategies can coexist, so I avoid forcing one model across the entire application. Make sure to cover when HTML is generated, caching behavior, interactivity, data freshness, SEO, runtime cost, hydration, and how Next.js supports choosing different rendering strategies per route. Question 3. How does React reconciliation work, and how would you prevent unnecessary re-renders? React compares the previous and next element trees, using type and key identity to decide what can be reused. I prevent unnecessary work by keeping state close to where it is consumed, using stable keys, splitting large components, and avoiding broad context updates. React Memo, use memo, and use callback can help when profiling proves value, but they also add complexity. I use the React profiler first, then optimize the specific expensive path. In your answer, discuss virtual trees, identity, keys, state boundaries, memoization, stable references, context propagation, profiling, and why optimization should follow measured rendering problems. Question 4. What are the key differences between the Next.js app router and Pages router? The app router is built around React server components, nested layouts, streaming, and collocated loading and error boundaries. The Pages router uses the older page-based model with APIs such as get server-side props and get static props. I prefer app router for new applications because it enables smaller client bundles and better composition, while recognizing that migration can expose differences in data fetching and routing behavior. I would migrate incrementally, preserving stable pages and testing caching carefully. Be sure to mention server components, layouts, nested routing, streaming, loading and error boundaries, data fetching, client components, migration considerations, and trade-offs in team familiarity. Question 5. How would you decide whether a component should be a server component or client component? I keep a component on the server unless it needs browser APIs, local state, effects, or event handlers. Server components can fetch data securely and avoid sending their implementation to the browser, which reduces bundle size. I mark the smallest interactive subtree with use client rather than promoting an entire page. For example, a product page can render server-side while its quantity selector remains client-side. This boundary improves performance and clarifies responsibility. Focus on interactivity, browser APIs, state, event handlers, data access, bundle size, serialization boundaries, security, and minimizing client-side JavaScript without sacrificing user experience. Question 6. How would you design a reusable, accessible component library for a product team? I would start with accessible primitives built on semantic HTML, then define tokens for color, spacing, typography, and motion. Components should expose composable APIs instead of trapping product teams in rigid layouts. I would test keyboard behavior, screen reader output, focus transitions, and responsive states, using automated checks plus manual verification. Storybook documentation, visual regression tests, and semantic versioning make adoption safer. Accessibility is a product requirement, not a final polish step. Cover semantic HTML, keyboard navigation, focus management, ARIA only when needed, design tokens, composability, API consistency, visual testing, documentation, versioning, and adoption across product teams. Question 7. How do you prevent hydration mismatches in a Next.js application? Hydration requires the server output and initial client render to match. I avoid rendering timestamps, random values, viewport checks, or browser storage during the initial render unless their values are passed consistently. Browser-only logic belongs inside an effect or a deliberately client-only component. When a mismatch occurs, I inspect the first warning, compare server and browser inputs, and remove the underlying nondeterminism. Suppress hydration warning is reserved for intentional, localized differences, not general fixes. Discuss deterministic rendering, server-client data agreement, browser-only APIs, dates, randomness, conditional logic, client-only boundaries, suppress hydration warning limitations, and debugging the first mismatching element. Question 8. How would you design caching and revalidation for a content-heavy Next.js site? I would classify data by freshness and personalization. Public content can use CDN caching with time-based or tag-based revalidation, while user-specific responses must remain private and avoid shared caches. After a CMS publish event, I would invalidate affected tags rather than rebuilding everything. I would inspect response headers and cache behavior in production, because a theoretically correct policy can fail through cookies or dynamic functions. The design should explicitly state acceptable staleness. Include CDN caching, request caching, revalidation intervals, tags, invalidation, stale content tolerance, personalized responses, cache headers, deployment behavior, and avoiding accidental cache leaks between users. Question 9. What happens during a browser navigation, and how would you optimize it? A navigation updates history, matches the destination route, loads required code and data, renders the new tree, and restores focus or scroll behavior. I optimize it by keeping shared layouts mounted, splitting route bundles, prefetching likely destinations, and showing an immediate pending state. I avoid prefetching everything on bandwidth-constrained devices. In a Next.js application, I would inspect route-level timing and real user navigation metrics to confirm that prefetching actually improves perceived speed. Mention URL handling, history, route matching, data loading, rendering, layout preservation, prefetching, pending states, scroll restoration, JavaScript execution, and measuring navigation latency. Question 10. How would you build a resilient form with validation, optimistic feedback, and accessible errors? I validate obvious constraints on the client for fast feedback, but treat server validation as authoritative. Each field gets a stable label, described error, and clear invalid state. After submission, focus moves to the summary or first invalid field. I disable duplicate submissions without blocking correction. For safe mutations, I can optimistically update the interface, then reconcile or roll back on failure. I also protect against CSRF, authorization mistakes, and trusting client-supplied values. Cover client and server validation, controlled versus uncontrolled inputs, submission states, optimistic updates, rollback, field association, focus movement, error summaries, retries, and security boundaries. Question 11. How would you implement authentication in a Next.js application securely? I prefer server-managed sessions stored in secure, HTTP-only, same-site cookies, so sensitive tokens are not exposed to JavaScript. Authentication confirms identity. Authorization must still happen close to each protected data access. Middleware can redirect obvious unauthenticated requests, but it should not replace backend checks. I would implement expiration and revocation, protect state-changing requests against CSRF, and avoid leaking user data through cached responses. Every root and server action needs an explicit access decision. Discuss session strategy, secure cookies, server-side authorization, middleware limitations, token exposure, CSRF, redirects, expiration, refresh, protected routes, and separating authentication from authorization. Question 12. What is your approach to state management in a large React application? I classify state before choosing a library. Form state and toggle stay local. Filters belong in the URL when shareable, and fetched data belongs to a server state cache. Truly cross-cutting client state, such as a theme or session display, can use context or a small store. I avoid duplicating derived values and remote data across stores. Clear ownership reduces synchronization bugs, improves testability, and keeps components understandable as the application grows. Explain local, URL, server, and global state boundaries, server state libraries, context limitations, cache ownership, synchronization, derived state, testing, and avoiding a single oversized store. Question 13. How would you investigate a slow page reported by users in production? I would first segment the report by route, geography, device, connection, and release, then compare real user LCP, INP, and CLS. A browser trace and network waterfall can reveal blocking scripts, slow data, layout shifts, or long tasks. I would use bundle analysis and server logs to connect client symptoms with causes. After forming a hypothesis, I would ship the smallest measurable fix, monitor its cohort, and roll back if key metrics regress. Mention real user monitoring, core web vitals, browser traces, server timing, network waterfalls, bundle analysis, device segmentation, regression comparison, reproducibility, and validating the fix after deployment. Question 14. How do edge runtimes change front-end application design? Edge execution can reduce latency by running request logic near users, which is valuable for redirects, personalization, and lightweight authorization. However, edge runtimes may lack node-specific APIs, and a distant database can erase the latency benefit. I would keep edge code portable, minimize dependencies, and place data near the execution region or use an appropriate cache. For heavy computation or incompatible libraries, I would choose Node.js deliberately rather than treating Edge as universally faster. Cover latency, geographic execution, runtime API differences, cold starts, request locality, database access, caching, portability, observability, and deciding when Node.js remains the better runtime. Question 15. How would you build an accessible, responsive dashboard with complex data tables? I would begin with a semantic table for simple datasets, giving headers stable relationships and accessible names for controls. On small screens, I might provide prioritized columns or a card view rather than forcing horizontal scrolling everywhere. Large datasets may need virtualization, but I would preserve keyboard and screen reader context carefully. Sorting and filtering should announce results, loading should retain structure, and focus should remain predictable after updates. I would test with real assistive technology. Discuss semantic table structure, responsive strategy, keyboard navigation, sorting, filtering, pagination or virtualization, screen reader announcements, loading states, contrast, and preserving usable interaction on small screens. Question 16. When would you use optimistic UI, and how would you handle failure? Optimistic UI works when the action is likely to succeed, reversible, and understandable if briefly shown before confirmation, such as liking a post. I update the local view immediately, track the pending mutation, and reconcile with the server response. Failure triggers a rollback and a specific, accessible error. For payments, destructive actions, or uncertain authorization, I prefer confirmation before changing the interface. Idempotent mutations and conflict handling make optimism safer. Include latency perception, mutation safety, temporary identifiers, rollback, conflict resolution, idempotency, offline behavior, error communication, and cases where pessimistic confirmation is safer. Question 17. How do you test a React and Next.js application effectively? I test behavior at the highest practical level. Unit tests cover pure utilities, component tests verify user interactions and accessibility, and end-to-end tests validate critical journeys such as authentication and checkout. I avoid mocking every implementation detail because those tests become brittle during refactoring. Visual regression helps shared components, while performance checks protect key routes. Coverage is useful context, but I prioritize risk, production failures, and meaningful user workflows over a percentage target. Cover unit, component, integration, end-to-end, accessibility, visual, contract, and performance testing, realistic user behavior, mocking boundaries, test maintenance, and confidence over raw coverage. Question 18. How would you reduce a JavaScript bundle without harming functionality? I would analyze the shipped bundle and identify large dependencies, duplicate versions, and code used by only a few routes. Then I would move non-interactive work server-side, add dynamic imports for heavy features, replace oversized utilities, and defer third-party scripts. I would also check execution time, not just compressed bytes, because parsing and running JavaScript affect interaction. Finally, I would compare builds and real user INP before accepting the optimization. Mention bundle analysis, tree shaking, dynamic imports, dependency replacement, server components, polyfill strategy, third-party scripts, route splitting, compression, and verifying execution cost rather than only transfer size. Question 19. How would you design a front-end deployment workflow for safe, frequent releases on Vercel? Every pull request should receive an isolated preview with automated tests, linting, type checks, accessibility checks, and representative environment variables. Production promotion should be controlled, observable, and reversible, with feature flags for risky behavior. I would coordinate database changes using backward-compatible migrations and verify caching after deployment. Vercel previews improve review quality, while logs, analytics, and release markers help detect regressions quickly. Safe delivery means reducing blast radius, not eliminating change. Discuss preview deployments, see checks, environment separation, feature flags, migrations, observability, rollback, cache invalidation, ownership, and protecting production while preserving developer velocity. Question 20. Describe a front-end architecture you would propose for a globally distributed SaaS product. I would organize the product around routes and domain components, keeping data fetching and authorization near server boundaries while isolating interactive islands on the client. Public content would use CDN caching, and personalized data would use private, region-aware access patterns. Shared UI would follow accessible design tokens and tested primitives. I would add error, loading, and empty states intentionally, then instrument navigation and API failures. The architecture should start simple, but leave clear seams for scaling teams and traffic. Cover route and component boundaries, server and client rendering, data ownership, authentication, caching, edge placement, accessibility, observability, testing, failure states, and evolving architecture without premature complexity. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.